polynomial, what they're going to give you are the zeros of that polynomial and then possibly another ordered pair for that polynomial's graph. And what you want to build is a polynomial of the correct degree that they ask for with that information. So the first example that we're going to do is find a polynomial of degree 3 with the zeros of -1, 2, and 4, and that f of 1 is equal to 3. So what they're saying is, okay, it's going to have these 3 zeros, and then you're going to build the polynomial, and if I plugged in 1 for x, it should equal 3 when you work it out. So what that's going to do is you're going to build this polynomial that's going to, in the end, look like this. But the a, the b, the c, and the d are going to be numbers. We're going to find those numbers that go there, okay? So it really starts with the zeros, though. That's the big thing, and that's why this is lumped together with the whole section about finding zeros. Because if we have the zeros, then we also have the factors that go with them, okay? So we know that this polynomial could start out like this. The factor that goes with x equals -1 would be x plus 1. The factor that goes with 2 is x minus 2. The factor that goes with 4 is x minus 4. The part that we don't have is that number that's in front of it all, the a value, the leading coefficient. We're going to call that a. Okay, so I'm going to put this a there hanging out, waiting for something to happen. So what I want to do is I want to multiply out all of this stuff first. Okay, or actually, it doesn't matter whether I multiply that out first or if I find a first. Honestly, it probably is easier to find a first and then just use a at the end. So let's do that. Let's go ahead and find a, because it's pretty easy in this step, and probably would be no more difficult in the last step, but I think let's go ahead and find it to be easier. So to find a, what this right here tells us is that when x equals 1, y is equal to 3. That's what that tells us, okay? So what we can do is take that problem and plug in a 1 for x and a 3 for y, and we should get what get the value of a in that problem, because everywhere there's an x, I'm going to put a 1. 1 minus 2 and 1 minus 4. A is the part I don't know. Remember that f of x is the same thing as y, so that should be 3. So I get this problem that's only got an a in the variable. So that's a times 2 times -1 times -3. 2 times -1 is -2 times -3 is -6. So that's -6a is equal to 3. Divide by -6. A is that's positive 6. I'm sorry. A would be positive 1/2. -1 times -3 is positive 3 times 2 is positive 6. A is going to be positive 1/2. Good to know. So that means I can go back up here to this spot, and I'm going to copy this. And instead of putting a, I can now change that a to a 1/2, because I know it's 1/2. You can either do that at the beginning or at the end of the problem. I think the math involved is probably easier at the beginning, because you're just plugging that x value in to the factors, and you don't have to deal with exponents and that sort of thing. So it may be a little less option of messing something up there. All right, so the next thing you want to do is multiply out those factors. And this is where it goes back to a couple of weeks ago when we were multiplying polynomials out. Okay, so we want to multiply out these polynomials. Okay, so we're going to multiply all of these things together. And doing 3 of them at a time is a little too much. So we're going to do 2 at a time and then multiply that answer by the third one. So I'm going to do these 2 first. X minus 2 times x minus 4. To do that, remember it's FOIL method or distributive property. X times x is x squared minus 4x. And then I'm distributing the negative 2. Negative 2x plus 8. I've still got this other stuff hanging out in the front. I ain't done anything with it yet. I'm going to simplify the parenthesis, the big parentheses there, and get x squared minus 6x plus 8. And then I'm going to multiply x plus 1 to the x squared minus 6x plus 8. So I'm just multiplying one step at a time. So x times x squared is x cubed. X times negative 6x is negative 6x squared. X times 8 is 8x. 1 times x squared is x squared. 1 times negative 6x is negative 6x. 1 times 8 is 8. Then I'm going to simplify that. That's a squared there. That didn't write it. So that'd be negative 5x squared positive 2x plus 8. Last step, distribute 1/2. Crystal, you got a question? Did I mess something up? It's possible. The x to the third should be right there. I'm sorry. I did mess something up. I said x to the third and didn't write x to the third. X to the third minus 5x squared plus 2x plus 8. And then I'm distributing 1/2 to all of that. So that's 1/2 x cubed minus 5 over 2 x squared plus x plus 4. And I've built a polynomial that does all of the, has the zeros that they told me, and it goes through the 0.13. I could verify that by graphing it and using the trace function on my calculator. I could trace all those x values that are zeros, negative 1, 2, and 4, and then I could, verify that they get 0, and then I could plug in a trace of a 1 and verify that it gets 3 on the graph. If it doesn't, then I did something wrong. Okay. So this is not a fun thing. It's long, it's tedious, there's a lot of steps. There's a lot of places that you can mismultiply, miss like I did, miswriting something down the right way, and it could cause problems. But it is one of those things that we've got to be able to do, is build a polynomial based on what we know from it. Let's look at another. We're going to look at a few examples of this and go Q. Let's build a polynomial of degree 3 with zeros, negative 2, multiplicity 2, and 3, and f of 2 equals 8. A little different. It says multiplicity of 2 on the negative 2, and then 3. There are zeros. And then f of 2 is equal to 8. Okay? So we're looking for a third degree polynomial. So we're going to start out with f of x is equal to a, and then I'm going to put my factors. What does it mean to be a factor? What's the factor that goes with the negative 2? What's the factor that goes with the 0 of -2? Plus 2, right? Multiplicity of 2 means that that factor happens how many times? Twice. So that means it's squared. What's the factor that goes with the 3? X minus 3, yeah. Okay. Again, finding A can be done at the beginning. It can be done at the end. I think the math's probably easier at the beginning because there's just adding and subtracting and then just very little. It's not as many places to plug it in, I don't think. So plug it in 8 and 2. And working those out. So that's going to be 4 squared is 16 times -1. And so that'd be -16a is equal to 8. So a is -1/2. That's what it tells us. It won't always be a fraction, just is on these, the ones I picked. I didn't pick the numbers probably. Okay. So again, I'm going to go back to my original thing. I'm just going to rewrite that with a being replaced by -1/2. There. Then I need to multiply this stuff out. And it doesn't matter what order you multiply it out in, as long as you multiply it all out. And y'all told me that to be x plus 2, a multiplicity of 2 means it happened twice. I put squared on that. Maybe it helps you to write it this way, out twice. Maybe that helps in simplifying it a little bit, is to write x plus 2 times. I wrote it with the exponent form because your book's going to write it. The test may write it that way. But know that that's what it means. It means that x plus 2 times x plus 2. What order you multiply these three things together in does not matter. I'm usually the guy that does it the same way every time. That way I've got a process and I don't mess it up. So I'm going to start with the 2 on the right and multiply those two together. X squared minus 3x plus 2x minus 6. It'll be -1/2 x plus 2 is x squared minus x minus 6. If you wanted to multiply the x plus 2 times x plus 2 first, you can. It doesn't matter. Then I'm going to distribute the x plus 2 to that. So that'd be x to the third minus x squared minus 6x plus 2x squared minus 2x minus 12. All right, and then the next step would be to simplify that parentheses part, and then we'll distribute the -1/2 from there. So x to the third plus x squared minus 8x minus 12. Final step, -1/2 x cubed minus 1/2 x squared plus 4x plus 6. So again, it's tedious, it's long. There's a lot of a lot of steps to it, but it's doable. Just don't get in too big a hurry, because that's where your mistakes are going to come in. Is you're trying to get in too big a hurry. Let's do a couple more of these, and then get the exceptions here. Or let's say degree 3 with zeros 3 and square root of 5. And I'll shorten it up here with a equal to 1. So I'll go ahead and give you a is 1. This one's a little weird because it says degree 3, but it only gave me how many zeros? Only gave me 2. So that must mean that there's something special about one of those. Well, which one of those looks weird? Square root of 5. What should also be a 0 that's in there? There should be another one. And remember that when we do square roots to solve something, when we solve a quadratic that has square roots, what has to go in front of that square root? Plus or minus. They gave me the plus one, right? They gave me the square root of 5. They did not tell me that the negative square root of 5 is there. They expected me to know that. It seems a little bit shady, but that's what they do, okay? You do have to recognize that, hey, if positive square root of 5 is a solution, then negative square root of 5 has to be a solution as well. We'll call that the hidden one. They didn't tell us about that one, but it's there. So that means I got to take care of it when I do my work, okay? So I'm going to build my polynomial, x minus 3, x minus the square root of 5, x plus the square root of 5. So I got to do some work with this stuff with the square roots of 5 in there. I will tell you, and a is 1, so there's technically a 1 out there in front. I'm not going to write it, but it's there. I gave you a on this problem, that a was 1, so there's a 1 in front of all of that. Okay. Now, with these problems that have the square roots in the zeros that they give you, I told you before, it doesn't matter what order you multiply stuff together in. What you want, it really still doesn't matter, but it will make your life a lot easier if you'll do the ones with the square roots together, and then get that answer and then multiply by the regular numbers. Okay, so pair up the ones that have square roots together. So do these two together first, and then multiply by the others. If you'll do that, the square roots will go away eventually. Okay. So I'm going to multiply those two together. So x times x is x squared. X times the square root of 5 would be x square root of 5. And then negative x square root of 5. And then negative square root of 25. See what I mean? The radicals will go away. The square roots will go away. Positive square root of x square root of 5 and negative x square root of 5 are going to cancel each other out. And then square root of 25 is 5. So that'd be x squared minus 5. So I really actually like these problems. They shorten up. They're ugly at the beginning and in the middle, but they shorten up really, really nicely for the last steps to be nice, and that's always helpful. Okay, so multiply x times x squared is x cubed, x times negative 5 is negative 5x, negative 3x squared, and positive 15. Only thing left for me to do is put it in the correct order. X cubed minus 3x squared minus 5x plus 15. And I've built my polynomial that does what they told me it had to do. All right. So square roots in there, got to remember that they're going to not tell you about both of the answers that are there. They're going to tell you one of them. You got to remember the other one exists with the square roots. Something similar happens when you're doing a problem that has zeros of 3 and 2 minus I with A equals 1. We'll just make it easy and put A to be 1. If 2 minus I is a solution, remember that with the complex numbers, those came from quadratic formula, and in the middle of the quadratic formula was that big plus or minus sign. And if 2 minus I is a 0, then what else has to be a 0? 2 plus I has to be a 0 as well. So this one is the hidden one. And everybody says these with the complex numbers in them are the toughest. I'm going to try to make it as easy as I can for you on these. It gets better, I promise. So here's how it works. Set them up. X minus 3. And then you've got the two factors with the complexes in there. So you have x minus 2 minus I and x minus 2 plus I. And you can just write them just like that. You don't have to have extra parentheses in there. Shortcut time. I'm going to show you the shortcut because it's easier, okay, than multiplying it out step by step. The shortcut is to multiply these two guys together first. Obviously, the same way we did the square roots. But the shortcut comes into multiplying it together. So what we're going to do is we're going to say x times x is x squared. And then to get that number that's in the middle, then that's going to come from the real part of that complex number, which is the negative 2's. Okay? The x minus 2 and x minus 2. If you multiplied minus 2 and minus 2 together, that'd be 4, right? And you change the sign. So it's negative 4. X. The real part, and then change the sign. Multiply those two things together, change the sign. Whatever number's there. If it were the complex zeros were negative 4 plus 5i, you would do that. Now, to get the number that's on the end, we're going to use the calculator. Because I can take 2 plus I times 2 minus I and get that number. It's the number 5. So I'm taking the two complex zeros and multiplying them together. And it stays the same. So it's plus 5. And then to get the 5, 2 plus I times 2 minus I. You just multiply the two zeros together. And then we have x minus 3 there. So that's the shortcut to getting the coefficients on that. If you forget the shortcut or can't figure that out, you can just multiply x times all those pieces, and then negative 2 times all those pieces, and then negative I times all those pieces, and then simplify. And it turns out to be the same. That's the beautiful part about the shortcuts. It works out to be the same. That's why it's a shortcut. If it didn't work out to be the same, it's not a shortcut. It's a U-turn. All right. So then we're going to multiply x minus 3 to all of that, which is a little easier. That'd be x cubed minus 4x squared plus 5x, and then multiply by negative 3, negative 3x squared plus 12x minus 15 Final step to simplify that, x cubed minus 7x squared plus 17x minus 15. And there we've built a polynomial out of that. Yes. Yes. That's the only time that's going to happen. That's correct. Only time that'll happen is if there's a square root or the I. All right. I am required by the department to tell you this, that you can look at Descartes' rule of signs. I don't use this very much at all in solving polynomials. But on page 313 in your textbook, there is a explanation of what Descartes' rule of signs is. What it does is just tells you how many possible positive and negative solutions you could have. Since you got, it was very helpful back when I was in high school and we didn't have the graphing calculators to help us see the actual zeros. You guys have that. So the Descartes rule of signs is not really that helpful anymore. There's an example on page 314. It's example 7 in your book. If you want to see how they use it, again, it's one of those. It gives you clues to help you pick the right numbers. I don't necessarily, like I said, we solved polynomials before break, and we didn't use Descartes' rule of signs at all. So again, I don't use it very much, but I'm by the Department of Math, I'm supposed to tell you Descartes' rule of signs exists, and you should know that it exists, and that if you want to read that section, you can. That's not anything that I'm going to ask you questions about Descartes' rule of signs. All right. On the last thing we need to talk about is in behavior of polynomials and describing the graph of polynomials without actually graphing it. So describing, and we're finishing up here. So this is not extreme. This is the lightest lifting that you will do today. We've done some pretty heavy lifting of mathematics today. So this is the light stuff. This is a good way to finish the day. I always want to end with a positive. This is the positive. Describe the graph of a polynomial by its in behavior and zeros if applicable. Zero is not always something we're going to use to describe. When it's handy, we will. But what we're going to do is describe it based on its in behavior. In behavior of a polynomial is based on its degree. Okay? So if the degree, I'm going to make a little table here. Degree, leading coefficient, and then left, right. I'm just making a little chart here. If the degree is odd, what does that mean? It means the highest exponent is an odd number, like 3, 5, 7, something like that. Doesn't matter what it is. The highest exponent in the problem is an odd number, and the leading coefficient is positive. So the number in front of the x to the third is a positive number. The left side of the graph will go down. The right side will go up. If the degree is odd and the leading coefficient is negative, it swaps. The in behavior swaps. Left side will go up, right side will go down. Okay. If the degree is an even number, so a quadratic is a good even example, x to the fourth power, x to the sixth power, anything such as that, then even graphs if they have a positive leading coefficient, then both sides are going to do the same thing. They're both going to point up. So this kind of goes back to when we talked about quadratics. Quadratics are an even polynomial, even degreed polynomial. If it had a leading coefficient of positive number, then it went up, it opened up. That's the same thing. If it's fourth power, it does the same thing. Now, if it's fourth power, it can do a lot of stuff in the middle, but both ends will both go up. If it's an even degree and negative leading coefficient, they're both going to point down. Okay. The zeros, we'll talk about that as we do some examples here. The only time we're going to, if it asks me for zeros, I have the skills to find them using the things we did before break. Okay. And I'm not going to ask you to do that, in the examples we're doing here, but we're going to just discuss where the zeros could be for some of these polynomials. Okay. So we want to describe the end behavior of the graphs without actually graphing them. The idea is that if we can look at a problem and if we actually graph it on the graphing calculator, it may be so large that we can't see the ends of it. But based on the knowledge from this chart, we should be able to tell what the ends are doing, because we know what happens to odd degree problems with a leading coefficient that's positive, odd degree with a leading coefficient that's negative, even degree with a positive or negative leading coefficient. We know that stuff, even if it won't fit on our graph. And that's what we're after here, is describing the end behavior. So I'm going to do a few examples of this and we're out of here. So describe the end behavior and degree of the polynomial. Okay, so I don't know what letter we're on. T. Won't quite get through the whole alphabet today. We'll get close. All right, so let's say we had f of x is equal to x to the third power plus 6x minus 7. I think if we graph that on the calculator, it would fit. But let's figure it out without it. What's the degree of that problem? 3. What do we know about the degree of 3? What's it tell us about the problem? There's 3 zeros. It tells us that. So that's relating it to the zeros. It tells us it's an odd degree, so we know the ends are going to go opposite directions. One's going to go up, one's going to go down. What's the left side going to do? Well, what's the leading coefficient? What's the number in front of x cubed there? It's positive 1. So it's an odd degree with a positive leading coefficient. So the left side's going to go which way? Down. The right side's going to go the opposite, up. Odd degree, you're always going to do the opposites. And you can write the word down or up. I just used arrows there for no apparent reason. Okay. But the degree is 3. It's odd. It has a positive leading coefficient. So that tells us left side down, right side up. Where it gets funky is when they might do something like this to you. They might say, okay, x plus 4, x plus 5, x minus 27. Yikes. That's not how I'm used to it. What form is that in? It's in factored form. But I can still pull the degree off without multiplying the whole thing out. Okay? What would happen if I multiplied these three together? What would be the degree? 3. X times X times X is X to the third. So the degree would be 3. What number is out in front of all this? It's a positive 1 again. So it's a positive leading coefficient, and it's a degree of 3. So again, the left side will go down, the right side will go up. Let's say we had 4 parentheses x minus 4 squared times x plus 7 times x minus 5. So 4 in the front, and then x minus 4 squared, x plus 7, and x minus 5 are my factors. What do we know about the degree of this problem? How much would it be? Degree of 4. Yeah, it'd be a degree of 4 because we have the x minus 4 is squared. So when I multiplied it out, it'd be x squared times another x is x cubed times this third x would be x to the fourth. So the degree is even, it's 4. What's the leading coefficient? Positive 4, right? So it's a positive leading coefficient, an even degree. So what's the left and right side both going to do? Both going to go up. That's what you got to be able to recognize out of that. Negative 2 parentheses x plus 5 squared minus, and then x minus 3. What's the degree of this polynomial? We got x squared and x. So that'd be 3, wouldn't it? X squared times x is x to the third. So there's a degree of 3. But the leading coefficient is negative 2. So what's that do to the left and the right side? They're going to go different directions. Left side's going to go up. Right side's going to go down. It flip-flops from what we had up here at example U. Okay, we got x squared here. The x plus 5 squared gets me x squared times this x on the x minus 3 gets me x to the third for the degree. The negative in the front tells me, oh, it's going to swap sides. So if I go back to my chart, odd degree with a negative leading coefficient, left side up, right side down. So that chart's going to be handy to have for you, when you're doing your practicing and getting ready for that test. That chart's going to be helpful. I'm I won't put that chart on the final on the formula stuff. That's something you're going to need to know. That formulas are, I'm talking about like quadratic formula, midpoint formula, distance formula, slope intercept form. Those are the kind of formulas I'm talking about. That chart won't be on there. What are all my problems doing? All right, and then let's do one more, and we're done. Complex. Let's say we had a tough one. I'll let g of x. 5x minus 1, and then x plus 3 squared, and x minus 6 to the third, and then a negative 8 in the front. This would be a very good example of one that will not fit in a graph very well. We wouldn't be able to see a lot of the ends on this one, I don't think. So we got factors. We got a 5x minus 1. We know that the 0 that would go with that would be, positive 1/5. We got the factor x plus 3, but it's squared, so that means that it's a repeated 0 at negative 3. We also know, just thinking about all the things we've talked about today, since this is the very last example of the whole course, talking about all the things we talked about today, we know that this 0, the graph goes through the x-axis. This 0 at negative 3, it's going to bounce off the x-axis. So it's going to come down, negative 3. It's going to probably, I don't know if it'll come down or come up, depending on what's happening before that. It would bounce off the x-axis like that. This 0 of 6, it's got an odd multiplicity, so it's going to go through the x-axis at 6. We know all of those things based on what we've done today. But what's the degree of the whole polynomial? So we got 3, 2, and 1. So it'd be 6, right? So it's an even degree, but a negative leading coefficient. So what's that mean the ends are going to do? Both go down. Negative leading coefficient, even degree. Both of them are going to go down. Okay. Some problems that you could look at for practice in your textbook for this sections, page 315, 5 through 111. Obviously, don't do all of those, but it'd be some good practice. Do a few from all of those would be great practice. Page 331, a much shorter set here, 21 through 27. Not many in that section there that would help you out too much. But make sure, you can take a polynomial, break it down. Don't forget you got the graphing calculator to help you. That's what it's a tool. It won't do all the work for you, but it'll do some of it. So definitely use that. Labs for the lessons that we talked about today are on, the videos are on YouTube. Videos from lecture on YouTube. You can go back and rewatch all of those to help you in prepping from today until next Thursday. It's your time to get exam 4 finished and prep yourself for this final. Don't forget, lab 27 is it's like a half practice final. It's the same material that will be on the final. It's just half the number, but it's 26 questions instead of 50. The final on Thursday of next week will be 50 multiple choice questions covering the entire thing we've covered all summer. So it covers everything. So make sure you're studying for that stuff. There is a practice final that that basically takes all of your chapter or your exams 1 through 4 and combines them and kind of just scrambles them up. It's got 100 and something questions in it, but you could take it as many times as you want to on Canvas, and that would be a good way to practice and study with that, because it's just going to mix it all together. So that'd be a good thing to do, is look at that as well. That's not for a grade. I'm not taking a grade off that practice final that's on there, but you can practice for your final. That's the idea. Remember, your final exam can also replace your lowest exam grade. If it's higher, it will replace it. If it's not higher, it won't replace any of those, but it will still count the 30% per the math department for that final exam. And then your labs, bring those with you on Thursday of next week and turn those in for sure. And that's 20% of your grade. So I haven't gotten through all of the labs that y'all turned in on Tuesday, so I'm going to work my way through those over the weekend, hopefully, and get all that done. And that should set you up for the final and be ready to go. Y'all got anything for me? Yeah, that'd be, yeah, you can absolutely do that. Shoot me an email so I don't forget to do that. That you want to know how am I doing on the labs and everything, and I'll send you a little synopsis of how your grades are looking so far. Yeah, no problem. All right, you guys are dismissed for the day. Have a great 4th and be safe. Don't blow any appendages off with fireworks.